solid sphere of mass m. So both are having mass m. So what are the first forces will be mg sine theta, normal contact, mg cos theta. Then there'll be normal contact by this also. If you resolve that, a component of that will be n2 sine theta, and this will be into cos theta. Then similarly, normal contact by the wedge on the sphere. It should be in this direction. Now, what is the acceleration of, in what direction it will move? It will be in this direction. Acceleration of the wedge A should be down the incline. Take like this. I think this will be much easier now. Now, how to decide the direction of friction? So let's describe the motion of the sphere with respect to the wedge A. So then the pseudo force is what I'm going to take it. Component of pseudo force will act towards left. And it has to roll. There's no slipping is telling. Enough to prevent slipping. So therefore the friction must act here in this direction. Then on the wedge, the friction has to act here. The weight mg. Okay, let's write all the possible equations. So for the wedge A, see all this based on the free body diagram. Once you should have a clarity of free body. Rest all we'll see. First we'll write the equation. What are the unknown things? To minimize, to overcome that unknowns, what further equations I can solve. So rather than fighting with the concept here, a student has to really put effort of free body diagram. So here the forces will be along the incline MA, acceleration this should be equal to mg sine theta plus n2 sine theta. Keep it here. N2A, so many unknowns are there. So then here N1 minus mg cos theta minus n2 cos theta equal to 0. This is the equation 1, equation 2. Then on the cylinder, on the uniform solid sphere, on the solid sphere, what are the equations we can write it here? So the equations what we can write here is like the F plus, so here this one MA cos 30. I think this should be the theta. MA cos theta minus F equal to M AX, I'll write it, or AR, I'll write it. AR is the acceleration of the cylinder in this direction. Let this be alpha. Alpha or AR. That how to get direction of friction. See, the direction of friction is, so now this will accelerate down, the wedge will accelerate down. Then this particular, you are going to stand on the wedge. Then you are going to put pseudo force MA. Component of this pseudo force will drag this sphere towards left, because this force will pass through center of mass. If a force acts on a rigid body at center of mass, the friction should be backward. I think for a solid sphere where the threshold point will come, the threshold point will come at 2r/5 above the center of the solid sphere. Above that, the friction will act forward. From threshold point to the lowest point, the friction will be backward. So therefore, friction will be backward. This component of pseudo force will try to move it, will try to produce translative motion. So point of contact will slip. So friction will be here. Then on the wedge, it should be towards left. Now condition for no slipping occurs. Sir, can't we think like this here? Because this pseudo force which is acting here will try to drag with respect to wedge, no? So therefore, there's the best way of doing problem. Try to do in ground frame, very difficult to analyze the friction. That's why I took the wedge frame. So MA cos theta, this one, MA cos theta minus F equal to MAR. So then rolling motion. What is AR? Acceleration of the sphere with respect to wedge. That's why I wrote AR. Acceleration of let it be. So this will be F into R equal to 2 by 5 mr square into alpha R. I think we have plenty of unknowns. What to do after this? We have one more normal contact. N2 also we can write it. So what is the expression for N2? MA2 sine theta plus N2 minus mg equal to 0. All these are related to the sphere. A condition for no slipping, what we can write. So here the acceleration AR minus R alpha R. That should be equal to minus of component of acceleration of the wedge along the direction, along horizontal. It will be A. This will be very important. Please do look at. So from where you have brought it. Okay, once again, let me take this wedge. Here I'm showing it separately. Only accelerations I'll show it. The acceleration of wedge is like this. No, you resolve this. How much you'll get? Acceleration AA sine theta. Acceleration of the wedge along x-axis because it is sliding down along the incline. Let me adjust the position of this. Come for this one. Oh, we have so much of space. No, acceleration of the wedge along A will be, because this angle is 30, so this will be 30 degrees. I'll write it a little bit big. Cos 30 will come. Cos 30. I'll make changes here. This will become AA cos 30, no? And acceleration of center of mass of the sphere is this one, and it's having alpha R. So it will be AR. This will be R alpha. R alpha R. Acceleration of these 2 points should be equal, no? For no slipping. So therefore, minus is what you have to bring. Component of friction, I didn't write. My equation 1, component of friction, I should write it, no? Okay, yeah, thank you. This will be minus F cos theta. Theta, I'll write 30 degrees. That will be better, no? Yeah, I made changes. So what we have to do is like just bring all expression for alpha R, R alpha R, substitute here. Expression for AR, substitute here. Expression for this acceleration, substitute here. Then what to do with N2? Again, this N2 you have to substitute here. This equation is a very fundamental. You have to dump everything in this equation. Then solve for friction. Once you get friction, then all other things we can find out. One, two, three. I have a lot of space. I'll do one thing. I'll push all these things. Yeah.
The second equation, we have to take a component of friction perpendicular also, no, sir. On wedge A.
On the wedge, yeah. Okay, this is the wedge. Anyway, that is this. We are very badly missing this one. Okay, now substitute 1, 2, 3, 4, 5 in equation 6. Then you have to solve. Can be asked. I think it's not that difficult. Can be attempted. Somehow what happened, the diagrams, the free body diagram, but you try to do this problem with respect to ground frame. The biggest headache is in getting the direction of friction. Getting the direction. So in the wedge frame only, the problem will become very simple. Value of normal contact force between the wedge and sphere. I think is asking to get the N2. N1 is not needed. Is asking anyway. This equation 2 is of no use. Substitute 1, 3, 4, 5 here. You have to work out. I'll slide down. I'll take the next question. Very simple. Moment of inertia of equilateral triangle plate of side length A about an axis passing through one of its vertices